What would happen if a nuclear weapon detonated today? It's a chilling question, demanding our attention as we navigate a world still shadowed by nuclear arms. To grasp this threat's gravity, we must revisit the time when the world witnessed nuclear power firsthand, Hiroshima and Nagasaki. In August 1945, these Japanese cities were forever changed by atomic bombs, marking the only use of nuclear weapons in warfare. The devastation was immediate. Buildings reduced to rubble, fires engulfing the landscape, and a death toll climbing into the hundreds of thousands. The world watched in horror as these events unveiled a new era of warfare, where a single bomb could obliterate entire cities. Beyond immediate destruction, Hiroshima and Nagasaki reminded us of nuclear technology's dual nature. An unprecedented force capable of ending wars swiftly, yet an existential threat capable of annihilating humanity. Today, the geopolitical landscape is more complex than ever. Nuclear weapons are central to global power dynamics, influencing political strategies and international relations. They are seen as powerful deterrents and threats that could escalate conflicts to catastrophic proportions. Countries worldwide, from the United States and Russia to emerging powers like North Korea, have built nuclear arsenals that can reshape our world instantly. Each nation's approach reflects their strategic interests and a broader struggle between maintaining global peace and the perpetual fear of mutual destruction. As we explore the history, mechanics, and geopolitical significance of nuclear weapons, we invite you to consider the shared responsibility we all bear. The power to destroy is also the power to choose peace. Can we envision a future where such weapons no longer threaten our existence? Stay with us as we delve deeper into this critical issue, uncovering the science, strategies, and scenarios defining our nuclear reality. Nuclear physics is the foundation for understanding the awe-inspiring power and profound danger posed by nuclear weapons. At the heart of these weapons lie two fundamental processes: fission and fusion. Let's embark on a journey to unravel these complex yet fascinating reactions that release immense energy. Fission occurs when the nucleus of an atom, typically uranium-235 or plutonium-239, is split into smaller parts by a neutron. This splitting releases a significant amount of energy, along with more neutrons. These neutrons can then initiate a chain reaction by splitting additional nuclei, leading to an exponential increase in energy release. Fusion, on the other hand, involves the merging of two light atomic nuclei, such as those of hydrogen isotopes, to form a heavier nucleus. This process releases even more energy than fission. Fusion powers the sun and stars, and in the context of nuclear weapons, it underpins the operation of hydrogen bombs. To truly grasp the magnitude of fusion's power, consider the Tsar bomber. Tested by the Soviet Union in 1961, it remains the most powerful nuclear weapon ever detonated. Its explosion unleashed a staggering amount of energy, equivalent to 50 million tons of TNT, demonstrating the cataclysmic potential of fusion when harnessed for destructive purposes. Understanding these reactions is crucial as they illustrate the mechanics behind nuclear weapons. However, it's not only about how these reactions occur, but also about how they sustain themselves through chain reactions. In a nuclear bomb, once initiated, the chain reaction proceeds rapidly and uncontrollably, releasing energy in a fraction of a second. This chain reaction is meticulously designed to maximize the explosive yield while ensuring that the reaction sustains itself long enough for most of the fissile material to undergo fission. As we delve deeper into the science behind nuclear explosions, it becomes clear that these processes are not mere scientific phenomena, but pivotal elements that have shaped modern history and geopolitics. The sheer force of hydrogen bombs, like Tsar Bomba, is a testament to human ingenuity and its potential for both creation and destruction. This exploration of nuclear physics sets the stage for understanding why nuclear weapons are viewed as both powerful deterrents and existential threats. Their capacity for unparalleled destruction compels nations to tread carefully in their development and deployment. As we transition from this foundational understanding to explore modern nuclear arsenals and their strategic implications, keep in mind that these scientific principles remain central to any discussion on nuclear capabilities and global peace efforts. Understanding them is key to grappling with the broader narrative of nuclear weapons in our world today. In the complex tapestry of global security, few threads are as potent or precarious as those of modern nuclear arsenals. The United States and Russia sit at the pinnacle of this formidable power, commanding the most powerful nuclear weapons known to mankind. As we delve into these modern marvels, we encounter two distinct categories: tactical and strategic nuclear weapons. Tactical nuclear weapons are designed for battlefield use, intended to achieve specific military objectives with limited range and lower yields. What elevates these arsenals' capabilities are systems like MIRV, or multiple independently targetable re-entry vehicles. Equally crucial are intercontinental ballistic missiles, or ICBMs. These missiles can traverse continents, delivering nuclear warheads across thousands of miles with precision. The combined might of MIRVs and ICBMs underscores a chilling reality. The sheer scale and reach of modern nuclear arsenals can reshape the world in moments. The existence of such powerful weapons demands a delicate balance. They serve as both a deterrent against aggression and a looming threat capable of unimaginable destruction. Understanding modern nuclear weapons is not merely academic. It is imperative for anyone concerned with our world's future. The journey through nuclear armament is far from over. In our next segment, we will delve into the immediate effects of a nuclear explosion. A nuclear detonation marks the onset of a terrifying sequence of catastrophic events. Within moments, the blast wave erupts, a wall of pressure racing outward at supersonic speeds. Buildings crumble, trees snap, and anything within its immediate reach is obliterated. This shockwave alone is a force of nature, capable of leveling cities and ending lives in an instant. Yet, the devastation does not stop there. Accompanying the blast is an intense burst of thermal radiation, a searing heat that ignites fires across vast areas, melting steel and turning sand to glass. This fiery phenomenon can cause severe burns to people miles away from the epicenter, leaving a scorched landscape in its wake. Simultaneously, an electromagnetic pulse, or EMP, surges through the air. This invisible wave has the power to disable electronic devices and communication systems over a wide radius, plunging entire regions into silence and confusion. In the modern world, such a disruption could cripple emergency responses and deepen the chaos following an explosion. But these are only the immediate effects. As the initial shock subsides, another peril begins to unfold: radiation exposure. The explosion releases a flood of ionizing radiation, penetrating living cells and wreaking havoc at a microscopic level. The impact on human health can be dire, with acute radiation sickness manifesting in the days following exposure. The lingering presence of nuclear fallout compounds the long-term health risks. Radioactive particles are lofted high into the atmosphere, carried by winds over vast distances before settling back to Earth. This fallout contaminates air, water, and soil, creating a toxic environment that poses ongoing dangers to all forms of life. Inhabitants of affected areas face increased risks of cancer and genetic mutations, with these effects potentially echoing through generations. The ramifications of a single nuclear detonation underscore the profound threat these weapons pose to humanity and the planet. As we continue our exploration, let us now consider how current geopolitical tensions might escalate these threats into reality. In the next segment, we delve into potential nuclear conflict scenarios and their implications for global security. In today's world, the specter of nuclear conflict looms ominously over us all. The geopolitical landscape is fraught with tension, evident in the flashpoints of Ukraine and Russia, the simmering unease between China and Taiwan, and the ever-volatile North Korea. Each region stands on the brink, where a single misstep could ignite a catastrophic conflict. But what if such a war were to occur? The risk of accidental war is ever present. In an age where the push of a button could unleash unimaginable devastation, the consequences of human error or technological malfunction are terrifying to contemplate. History has shown us how close we've come to disaster during events like the Cuban Missile Crisis. Could similar circumstances repeat themselves in our time? Enter the MAD doctrine, mutual assured destruction, a concept that has both deterred and haunted us since the Cold War. This doctrine ensures that any nuclear aggression would be met with equal or greater retaliation. effectively guaranteeing the destruction of both the attacker and defender. As we explore these scenarios, we must ask ourselves, are we truly prepared for the potential fallout of such conflicts? The doctrine of deterrence may have kept large-scale wars at bay, but it also assumes rational actors and flawless systems, a dangerous gamble in an increasingly unpredictable world. The scenarios we've explored remind us that the threat of nuclear conflict is not just a relic of the past, but a present danger that demands our attention and understanding. As tensions continue to rise globally, it's critical to consider how these complex dynamics could unfold and what measures can be taken to prevent such devastating outcomes. As we transition to our next segment, we will shift our focus towards the future, examining new technologies like hypersonic missiles and AI military systems, as well as exploring pathways towards global disarmament. Join us as we delve into the evolving landscape of nuclear weapons and the quest for peace in our time. As we stand on the brink of technological evolution, the future of nuclear weapons looms large, with both promise and peril. Hypersonic missiles and AI-driven military systems redefine the landscape, pushing the boundaries of speed and precision. Yet, they also raise ethical and strategic questions, challenging our understanding of deterrence and defense. In parallel, disarmament efforts continue to chart a path toward global peace. International treaties have played pivotal roles in reducing arsenals and fostering dialogue. But beyond the ominous shadow of warfare, nuclear technology holds immense potential for peaceful applications. From powering cities with clean nuclear energy to revolutionizing medicine through radiation therapy, the benefits are significant. However, the journey toward a safer world is fraught with complexities. As nations grapple with balancing power and peace, the role of emerging technologies becomes increasingly critical. The integration of AI in military strategy and the development of hypersonic capabilities demand a new era of international cooperation and ethical consideration. Yet, amidst these challenges, there lies an opportunity, a chance to harness these innovations for the greater good. By investing in research and diplomacy, we can transform potential threats into tools for peace and progress. As we conclude this exploration of nuclear weapons' future, we are reminded of the weighty responsibility that comes with such power. The decisions we make today will shape tomorrow's world. It is up to us to choose a path that leads to safety, stability, and a legacy of peace. This journey does not end here. It transitions into an era of reflection and action. In our next segment, we'll delve into the long-term implications of nuclear arsenals and confront the pressing question: can the world ever truly be free of nuclear weapons? Join us as we navigate these crucial discussions and envision a future defined by hope rather than fear. As we reach the conclusion of our journey, we stand at a crossroads that has defined much of the past century. The specter of nuclear weapons continues to loom large over us. Their existence is a reminder of humanity's capacity for both creation and destruction. We've traversed the history, mechanics, and geopolitical intricacies that have shaped the nuclear landscape. The long-term risks are undeniable. From the chilling devastation witnessed in Hiroshima and Nagasaki to the modern arsenals capable of unimaginable destruction, nuclear weapons pose an existential threat that knows no borders. But in this moment of reflection, we must ask ourselves, can we envision a world free of nuclear weapons? This question is not merely rhetorical. It challenges us to imagine a future where disarmament is not just a diplomatic gesture, but a global commitment. The road to disarmament is fraught with challenges, yet it is a path worth exploring for the sake of future generations. As technology evolves, so too must our efforts to secure a safer world. The dialogue around nuclear disarmament must persist, as must our dedication to innovative solutions and peaceful applications of nuclear technology. Now, we leave you with this thought. In a world filled with complexity and uncertainty, could a future without nuclear arms be within our reach? The choice lies with each of us to advocate for change and to envision a legacy of peace. As we close, let these powerful visuals and stirring music serve as a reminder of what is at stake and what can be achieved. Together, let's ponder the possibilities of a world where the threat of nuclear weapons is but a distant memory. Thank you for joining us on this journey.